This is the third and last video for this week of April the 13th to April the 19th, and it's going to cover Chapter 14. When you come back next week, we're going to start talking about dinosaurs. But we're done with the Paleozoic era, which is the first era of the Phanerozoic eon. And please don't forget the Paleozoic era covers 542 million years ago to 245 million years ago. Cambrian, Ordovician, Silurian, Devonian, Mississippian, Pennsylvanian, Permian. There was a great mass extinction 245 million years ago. Pangea came together 245 million years ago. Please don't forget that. And 245 million years ago, a new world begins, and it's called the Mesozoic era. The Mesozoic era began 245 million years ago and ended 65 million years ago. So fair warning on the test, there's made some questions on these ages of rocks, for example. This rock is 390 million years old. What era did it form in? Well, Paleozoic, Mesozoic, or Cenozoic? You should be able to answer that question. The Mesozoic era is an era which began with Pangea coming together, this great mass extinction at the end of the Permian, where 95% of marine invertebrates became extinct, and 50% of vertebrates became extinct. And here, where you see this picture, it's straight out of the book, and there's a yellow arrow. And this blue area here is the Mesozoic era. And there's 3 periods of the Mesozoic era to remember. The first period is the Triassic, Triassic. The middle period is the Jurassic period, Jurassic. And the last period of the Mesozoic era is the Cretaceous period. And the Cretaceous is spelled like this, Cretaceous, Cretaceous. The Mesozoic era is called the Age of the Dinosaurs. The Mesozoic era is famous for dinosaurs. If you find dinosaur fossils in a rock, you know it's Mesozoic. We've never found a single dinosaur fossil in the Cenozoic or the Paleozoic. Dinosaurs appeared on the planet during the first period of the Mesozoic era, called the Triassic, and they died out at the end of the Cretaceous, the last period of the Mesozoic era. Here's some important things that happened during the Mesozoic. Pangea broke up. The Atlantic Ocean formed. The Rocky Mountains formed. Vast amounts of petroleum formed all around the world. Gold and other ore deposits were formed. What's the first period of the Mesozoic, ladies and gentlemen? You're right, it's the Triassic period. And this is what the planet looked like in the Triassic. You can see that we had one continent called Pangea, Pangaea. And during the Triassic, we had one continent, the Pangea. What period comes after the Triassic? The Jurassic. You can see during the Jurassic, North America started to break away from Eurasia. Gondwana, all of those southern continents, Australia, Africa, South America, Antarctica, and India too, which is called Gondwana, started to break away from North America. So since you had Eurasia breaking away from North America and Gondwana breaking away from North America, you started to form the very beginnings of the Atlantic Ocean. So the Atlantic Ocean started to form during the Jurassic period. It was very narrow during the Jurassic period. What period comes after the Jurassic? Cretaceous. So during the Cretaceous period, You can see Eurasia broke apart. It's far away from North America. Greenland had formed. Notice there's a seaway going through North America, all the way up to Iowa. But most of out west, Idaho, Washington, not Washington, Montana, Wyoming, New Mexico, Arizona was all underwater. It was under this Cretaceous interior seaway. So North America was split into two parts: this island to the east, and this big rocky mountain to the west. Gondwana had broken apart into all of the southern continents: South America, Africa, India, and Antarctica. So the Mesozoic era is a story of the Atlantic Ocean forming and Gondwana breaking away from North America, and then Gondwana itself breaking apart. India is just an island here. Later on, we'll talk more about India, but for now, just remember it was just an island during the Cretaceous. Mesozoic era has a lot of these evaporite deposits. What are evaporite deposits? These are chemical sedimentary rocks that form from the evaporation of water that formed in rift valleys. And these evaporite deposits formed in the places where the continents were breaking apart. This shows you two pictures of our planet. Here's what the planet looked like during the Triassic when we had Pangaea. And here is what it looks like during the last period of the Mesozoic, called the Cretaceous. You can see that these yellow arrows show you ocean currents, and a lot of the ocean currents going from east to west or west to east were blocked by Pangaea. Whereas by the end of the Mesozoic, during Cretaceous time, we had lots of east-west currents and west-east currents. That's real important. That's very important in terms of climate, because what it means is during the Triassic period, since you didn't have east-west currents due to Pangaea being there, that means the world's continents were mostly dry during the Triassic. That's why you had all those evaporites. Lots of deserts covered the planet during the Triassic period, the first part of the Mesozoic era. But by the time you got to Cretaceous time, these ocean currents were moving east-west, west-east, and that allowed for a lot of precipitation. So by Cretaceous time, the deserts were mostly gone. You had forests. You had wetlands. And we're going to see in the next chapter how that affected life. But during the Triassic period, I'll give you a clue right now. During the Triassic, the first period of the Mesozoic, since conditions were dry, that gave the dinosaurs the opportunity to take over the planet, basically, because dinosaurs don't need as much water as other large reptiles and amphibians. Definitely need water. Dinosaurs excrete very little water when they go to the bathroom, and therefore they don't have to drink as much water. So when conditions became dry, and other creatures, especially the amphibians, got wiped out, the dinosaurs took over during the Triassic period. But when conditions became wetter, the dinosaurs still had advantages, and we'll talk about that, because they still dominated to the very end of the Mesozoic era. This shows you North America during the Triassic period, the first period of the Mesozoic. And don't forget, the Appalachian Mountains are Paleozoic in age. They formed 290 million years ago. But by Mesozoic time, they're starting to wear down some. You can see in the erosion of the Appalachian Mountains produced a large amount of sand to the west of these mountains. So the erosion of these mountains produce sand. Rivers carry that sand out west, and you form this large sandy plain. Big thing that happened in the Mesozoic is we start to get mountain building on the west coast. Real important to know. During the Paleozoic, our mountain building, our subduction occurred on the east coast. During the Mesozoic and going all the way to the Cenozoic, almost all of the mountain building occurred on the west coast. Don't forget that. So, which mountain ranges are older? The Rockies or the Appalachians? I'll give you a few seconds to think about that. The Rockies are younger mountains formed during the Mesozoic. That's why they stand tall and they look rugged. They look young. The Appalachians look worn down. They're an old mountain range. By Jurassic time, look how much the Appalachian Mountains have worn down quite a bit. This is all that's left of the Appalachians by Jurassic time. It's still shedding off sediment to primarily the west and northwest. But on the west coast, we get major mountain building due to subduction on our west coast. And so you have this, let's go back here, Triassic to the Jurassic. During the Jurassic, and the Sundance Sea and the Pyrrhic Sea separated North America into two islands. This mountain here is based on the Appalachians and the sandy plain to the west-northwest. And this long, rocky island, mountainous island here, formed by subduction on our west coast. These will later on become the Rocky Mountains. And then you had this shallow sea in the Pyrrhic Sea called the Sundance Sea. The Sundance Sea separated North America into two islands during the Jurassic period. Sundance Sea, Jurassic period. What's the last period of the Mesozoic? The Cretaceous. Let's see what happened in North America next. During the Cretaceous, the Appalachian Mountains continue to wear down. The Rockies, which is called the Cordilleran Mountain Belt, and I'll spell that for you. Cordilleran. Don't get confused by this word, Cordilleran. Cordilleran, what does this word mean, Cordilleran? It means the Rocky Mountains, which continue all the way south down to the Andes Mountains. That whole long mountain range from the Rockies down to the Andes in South America is called the Cordilleran. But in North America, we call our part of the Cordilleran the Rocky Mountains. The Rocky Mountains were formed during the Mesozoic era. But the difference is, during the Jurassic, we had the Sundance Sea separating North America into two islands. Sundance Sea retreated so that these two islands were connected to the end of Jurassic. And then during the Cretaceous, a new Pyrrhic Sea separated the North American continent into two islands, and that's called the Cretaceous Interior Seaway. How do we know this? Well, it's easy. We look at fossils here from the Cretaceous. We find oysters. We find corals. We find fish, marine fish in these rocks, in these states. So we know there was an interior seaway called the Cretaceous Interior Seaway that divided North America into two islands. This is another important thing here, and these are called Triassic fault block basins, and the Triassic fault block basins can be found going all the way up here to Canada and Newfoundland and near Halifax, Massachusetts, Connecticut, Pennsylvania, Maryland, Virginia, and North Carolina. These Triassic fault block basins, what do they look like? Well, let me see if I get a picture so I can show you what they look like. This is what they look like. These are rift valleys from the plate tectonics chapter. And they are formed by divergent plate boundaries, by pulling apart rocks. So we find these rift valley deposits, these horse and graben at these locations. think about it. It's pretty interesting. This is an ancient Rift Valley right here. Another way of saying it is, this marks the line where Africa broke off from North America. Yes, Africa was connected to North America. So was Europe. And they broke apart along this line right here. When I was a young kid, my parents took me to a place right here called Palisades, New Jersey. And I was 7 or 8 years old. And one of the things that got me interested in geology is the park ranger pointed to the rocks here. And he said, the rocks we have here in Palisades, New Jersey are the same rocks that we find in Africa. How can that be? I wondered. Well, it can be because Africa was connected to North America right here. And this is the place where these Triassic fault block basins is the scar left behind by Africa and Europe pulling away from North America. There it is, Palisades, New Jersey, if you ever get a chance to see it. And I'm going to inject some of my horrible humor here. Let me show you here. So, Palisades Park. Palisades Park, New Jersey. And Chuck Barris made a song about it. And here it is. Legendary rock and roll from the 1950s about Palisades Park, New Jersey. Last night I took a walk after dark. I swing a place called Palisades Park. To have some fun and see what I could see. That's where the girls are. I took a ride on a shoot. The girl I sat beside was awful cute. And when we stopped, she was holding hands with me. My heart was flying up like a rocket ship, down like a roller coaster, fast like a loop-de-loop, and around like a merry-go-round. We ate and ate at a hot dog stand. We danced around to a rockin' band. And when we could, I gave that girl a hug. In the tunnel of love, you never know how great this can feel when you stop at the top of a Ferris wheel. When I fell in love, died at Palisades Park. We ate and ate at a hot dog stand. We danced around to a rockin' band. And when I could, I gave that girl a hug. In the tunnel of love, you'll never know how great it can feel when you stop at the top of a Ferris wheel. When I fell in love, down at Palisades Park. Down at Palisades Park. You know it's Palisades Park. Anyway, I thought you'd like that. Music from 1960 about Palisades, New Jersey. Another thing happened during the Cenozoic is we formed a lot of oil. And the oil was formed here in the Gulf Coast area. And that's where we're drilling for oil offshore in the Gulf of Mexico right now. And this oil was concentrated around coral reefs that existed all the way into Mexico, to Louisiana, and into parts of Texas. So we had formed a lot of oil, and we formed a lot of gold. Why did we form a lot of gold? Because we had subduction occurring on our west coast of North America, producing the Rocky Mountains. Our mountain building occurred on our west coast during the Mesozoic. Don't forget it. Paleozoic, it was on the east coast. And when you have mountain building, you have lava rising, heating up water around these igneous intrusions. As this hot water rose, it concentrated gold. And that's what the 1840s, we had the gold rush. And People went out by stagecoach out west to search for gold. I remember I was there in the 1840s. And I searched for gold all the way up to the 1850s, into the War of Northern Aggression, when I fought in Stonewall Jackson's army, and I watched Atlanta get burned down. Just kidding. Anyway, we had mountain building occurring on our west coast during the Mesozoic era, not on our east coast. Those are called the Cordilleran orogenies. We have batholiths, that's igneous intrusive rock, here all along our west coast, going up into Canada, British Columbia, Washington, Oregon, California, the Baja Peninsula. Why? These igneous plutons were formed by subduction on our west coast during the Mesozoic era, forming the Rocky Mountains and the Coast Range Mountains up here in Canada, and then the Sierra Nevadas here in Nevada. So these West Coast mountains are formed during the Mesozoic and the Cenozoic. And we continue to have mountain building on our west coast. One of the most famous features about that is Mesozoic in age in North America that I hope you get to visit someday when you graduate from your own state and you start to form families and travel and all that. You see the petrified forest in Arizona. And you have all these tree trunks there they're exactly, every little nook and cranny in there looks like wood. You can see the holes that the insects left behind. But the trees have been turned into rock. And that's why we call it the petrified forest, which is Mesozoic in age in Arizona. We find dune deposits, especially when during the Triassic and the Jurassic, when the continents were drier. Another thing that you want to see when you go out west to Vernal, Utah, is called the Morrison Formation, world famous for dinosaurs. More dinosaurs have been found in Morrison Formation than any other rocks on our planet. Tyrannosaurus rex, Triceratops, ornithopods, pachycephalosaurs, stegosaurs, sauropods, they've all been found in the Morrison Formation, famous Mesozoic formation of rocks. And Dinosaur National Monument is located there in Vernal, Utah. And paleontologists have to work with all these bones and put them together into a skeleton. So when the dinosaur died, sometimes the separate bones got torn apart and carried down by a creek or a river, and then they're in a big jumble. And you got to put these together to make this entire skeleton. Or there could be several dinosaurs in this accumulation of bones. It's quite a challenge for a paleontologist to put these bones together to see what the whole dinosaur looked like. A friend of mine can do it. Her name is Barbara Grandstaff, and she can tell, oh, that's an ankle bone. Oh, that's a thigh bone. Oh, that's a part of the skull. And she'll even know what part of the skull it is. And they take these back to the lab, and they work on them, not destroying any of the bone, and putting them all back together. So during the West Coast, during the Mesozoic era, all of this land here was added onto the western margin or the western edge of North America through mountain building, through subduction. All of this land here didn't exist before the Mesozoic. Much of California did not exist until the Mesozoic. This was the coastline here where the green ends during the end of the Paleozoic. All of this land was accreted on, that means glued on, to the edges of western North America through subduction. That's it, ladies and gentlemen. Next week we'll be doing chapter 15. I hope all of you are staying safe and keep your email boxes clean so you keep on receiving emails. And watch the videos once or twice if you're not doing good, because I want you to do good. I really do care that people do good, but you got to put in the work and take notes and try and summarize the information in your own words. Know the terminology. See you next time.